Why should we have Rust in production? In line with all of our systems, our core business needs to be able to operate efficiently and at scale. We also need to have a high level of reliability because our business depends on it. Users are connecting in and they need to have a certainty. Is my app gonna work? Are things gonna be proceeding forward? If you're using Rust, the answer is most definitely, well, probably yes. Rust takes that one step further and it adds a lot of extras that help ensure not only extreme performance, the important added reliability that it brings with it is paramount. So we'll be doing a walkthrough here today with why Rust in production by Corrode. Oh wait, Rust? I see, okay. It's corrosive like Rust, I get it. One of the main reasons that Rust has surged in the recent years with tech giants such as Microsoft, Google, and Amazon are for the core principles that Rust brings along with it. Memory safety is huge, and it becomes even more difficult when you need to have a concurrent system leveraging multiple cores on a machine. Rust has this baked in as a foundation and streamlines a lot of that process for you, so you don't have to deal with memory safety. Those are the core problems that we tend to run into, especially in production, those memory errors, and it happens with so many different languages. However, with Rust, this is a key component to the success. Even Microsoft mentions that 70% of their bugs are due to memory safety issues. Rust has great reasons, really good reasons for being used and leveraged in production. And the key tenets there is really simple and straightforward: reliability and stability. Wait, aren't those two very similar? I think they're those two are very similar words there. Well, I guess you could have an unstable, reliable app or a reliably unstable application. I guess you could, but it might just make, let's add both. Let's get the best of both worlds. Depending on the scale of your needs, most companies care less about the performance power of Rust and more about the stability. More and more businesses are dependent on technology, and having something that can offer a high level of stability and reliability means less problems down the line when it comes to business and opportunities. Also, from an opportunity cost perspective, the predictable nature of Rust becomes an easy to maintain and cheaper to operate prospect. You don't need to spend so much time debugging. The compiler helps solve most of those issues up front, even before you put it into production. Corrode.dev here shows us a nice quote: "Given our small team size, infrastructure reliability is crucial. Otherwise, maintenance will starve innovation. Rust provides us with the confidence that any code modification or refactor is likely to produce working programs, and they will run for months with minimal supervision." This comes from from Twitter, okay, or Twitter. As we adopt more Rust at PubNub, I can definitely explain that this is a shared experience that we have as well. We are driving forward with using as much Rust as we possibly can. As we're reviewing reasons for Rust in production, we are looking at all the good outcomes and the capabilities that Rust offers us. Rust is so reliable and so stable in production. I was reading through the article here on corrode.dev. There's an example here that the NPM, which if you're familiar is like, I guess, Node Package Manager. If you're familiar, this is the JavaScript ecosystem. NPM is like the crates.io for packages of JavaScript, which means that you can leverage open source libraries that you can import into your package.json file, and that allows you to take advantage of the open source technologies that are already written by other community members. And what's interesting, the JavaScript community migrated to Rust. They did this several years ago, and there's a white paper even. We got to check that out. And it was so critical. They did this because it's upwards of 1.3 package downloads per day necessitated the need for NPM to leverage Rust. Crucial infrastructure for the JavaScript ecosystem and stability of its services. I love that. That's my favorite. And here's the case study for Rust with community makes Rust an easy choice for NPM. So they have over 1 million packages, and each month 30 billion packages are served for as you're running, NPM install. And those downloads come from over 10 million users, and their problem is CPU. JavaScript will like to use your CPU. When you go to a language like Rust, you're going to have a much better performance CPU. JavaScript, being a just-in-time compiler, can only achieve so much efficiency. If you're looking to use Rust in your application instead, you're going to get a much better performance on the CPU utilization. And based on the charts here, we can see why, as the growth rate of NPM packages are being downloaded, they needed to switch to Rust. The biggest compliment to the Rust is that it's boring, and it's an amazing compliment. It is an amazing compliment. That's from Chris Dickinson, engineer at NPM. performer. Yeah, I guess you could say Rust is boring from a runtime perspective because it just kind of does what it's supposed to do and there's no surprises or gotchas. Boring from that perspective. I would have to say, though, it is exciting as you're developing with this language. You have to relearn a lot of things. This is actually one of the challenges with Rust is there's a high barrier to entry. More than often a complicated language to learn and doesn't follow a lot of the common patterns that you might have learned in like a traditional education institution. So we're talking about using Rust in production and basically the reasoning about this. It is more stable and reliable. And we're looking over here at corrode.dev. In more details, I specifically like to look at this one right around here. As we deploy bugs, often they even make it their way into production. They are always a problem in terms of cost, and they're expensive and time and opportunity loss and maybe customer frustration. These are problems. And the longer the bug lives in production, maybe it goes unnoticed for a while because it only affects maybe just a few people at once. That bug will become more expensive as time goes on. You'll eventually notice it, and by then it's too late. You'll have a lot of investment to make into fixing that bug. One of the great bonuses with Rust is that we don't have to worry as much about certain bugs because the compiler will catch the majority of those problems for you. And we have this nice chart here that describes where the relative cost to fix bugs based on the time of detection. Early on at the beginning, right, it's kind of like the baseline when you're just developing and collecting the requirements. And then, of course, coding. So if you catch those bugs or like logic or architectural bugs early on, you haven't really invested into the code, so there's not technically a bug. You haven't implemented it yet. But once it gets the coding and it's implemented, then you'll have a 5. I'm not exactly sure where these numbers are coming from, but I do agree with the sentiment of them. Once you hit integration, there's about twice as difficult to debug, and then you hit production, and then apparently it's 30 times more difficult. Yeah, I can definitely say post-release bugs are the most difficult to discover. And once you have a reproduction of that bug and you're able to discover where it is, fixing the bug is still a problem at that point going forward. One of Microsoft's famous surveys is they show that 70% of their bugs are due to memory safety issues. One of the advantages of Rust is that it detects and prevents these kinds of bugs. The compiler takes care of memory management for you. There isn't a garbage collector, it just manages the memory specifically based on its scope rules. And it drastically reduces and almost entirely eliminates the majority of the bugs that you will put into production. This isn't to say that all bugs are magically fixed, because you still can have logic bugs or architectural challenges, maybe some bottlenecks here or there from scaling perspective as you're interacting with databases and other kinds of systems. But if you go with Rust, you immediately solve the vast majority of the bugs that you would have put into production. Rust is fantastic for high-scale production systems. Building your application in Rust is a very big benefit to every business that makes a decision to leverage the power of Rust. Rust is able to provide you with this powerful capability through its strong typing system and borrow checker. It catches bugs early in the development lifecycle because those bugs are found at compile time. This is in a contrast at runtime, where languages typically have less stringent type systems. Even systems that have static analysis capabilities like TypeScript, which are transpiled languages into JavaScript, they still cannot create as good of a cost savings governance as something like with Rust compiler. If you're building for scale, you're going to have a scenario where you probably run into using languages like Go and other kinds of systems that are built for web applications. At scale, you'll see companies like Discord and Cloudflare describe that one of the reasons of using Rust in production instead of another language provides a nice, smooth experience. We've had this experience as well at PubNub. Our web APIs are that much more performant and available with the power of Rust. Even taking a look here, we see something called Firecracker at AWS is an efficiency improvement to Fargate. And I heard also Lambda as well. They were able to reduce the price of Fargate by 50%. That's because, I see, okay, so the runtime for memory requirements and the CPU consumption is that much more efficient with Rust. The ergonomics of Rust have provided a new developer experience, shifting the static analysis and quality assurance up front in the development cycle compared to the traditional languages and deployment process. So we look at here a nice little chart that describes how Rust evolves throughout the development lifecycle. We see that the problems that you usually run into from a software perspective as we're developing our products, Rust is able to pull all those forward earlier on. Now this is the part, if you've used Rust before, where the compiler will just start yelling at you. all the time. It'll even yell at you and say, hey, you should do this thing right here that I told you the exact thing to do. When you run into an error, the compiler will say, do this. You're like, okay, I'll do that. I'll grab this and put this here. And then you do it, and then suddenly the compiler will yell at you again for some other reason. And so with this strict compiler, it will sort of force you into a new way of development that pulls all those challenges and bugs up front into the development lifecycle as you're actively building the code. So we can see here in this quote, Rust has been a force multiplier for our team, and betting on Rust was one of the best decisions we've ever made. More than performance, its ergonomics and focus on correctness has helped us to tame the sync's complexity. Oh, syncs. Aha, that's why. This is a Dropbox quote. Okay, I get it. What they do is they encode complex invariants about their system into the type system, which is the Rust type system. And this allows the compiler to check those for them, which means they're sort of leaning on the Rust compiler to take care of as much as possible. So we've heard from pretty big companies here. We've got AWS, Microsoft, Google, Cloudflare, Dropbox, NPM, Node Package Manager. And I even heard that Linux has started importing some of the, here we go. All right, so the Linux kernel now supports Rust as well. Oh, that's huge. This is the only time, this is like the second language, I think. Basically, it's all C, right? Linux is written in pure C, and not even C++ is allowed to go into Linux kernel. But Rust is. That is amazing. Rust has one additional key advantage, well, probably more than just one, but this one is in particularly interesting. Being able to provide productivity and developer happiness. Many developers enjoy working with Rust. Now that's true after you've already gotten past that initial hurdle of the complexities that come working with the Rust compiler. My first-hand experience working with Rust is type, click the button, compile, cargo build, and then pages of errors. Just tons of errors, because I was programming in a way that I learned in a more traditional educational environment versus something that's more of a Rust-oriented way of development is just a little bit different. But once you get past that, the developer happiness kind of hits the ultimate, as it's the most admired language for the 6th year in a row, according to the Stack Overflow developer survey. It said 80% of developers that use it want to use it again next year. I guess that means that 20% don't? I mean, it's possible those 20% have run into that initial barrier of just kind of getting on board with Rust. Rust in production, when you're thinking about it from a business perspective, is unmatched. Let's think about it from an operation standpoint of how many servers you need to lease in order to operate the software. When the code is written in Rust, you're going to have a much more efficient system. Not only are we saving energy, but we see here that Rust has a superior runtime performance on par with C and C++, faster than Go by a factor of 2 to 3x. Ooh, and faster than Python than 70x. So that's a lot faster. Here we see we've got a table. C is the baseline where we have a time normalized as 1. So that's like the industry standard for performance is C. Then we go one step further and you got Rust, which is basically at the C level. C++ is a little bit worse off here, which is interesting. I kind of always thought C++ would be almost the same as C, but Rust beats C++. And then, Java and Go, we see these two things are kind of about the same. You bucket these two languages together, followed by JavaScript, PHP, Ruby. Wow, Ruby's got some challenges there. And then Python at the very bottom. Now, it's interesting to see Python here at the bottom, as it's one of the most prevalent languages, especially today with a lot of AI. PyTorch is a library that sits on top of libtorch that's written in Python. Libtorch is written in C, where Python is able to have bindings into that library. And it is the most popular and prevalent language when it comes to AI development. Here's a nice little chart when it shows the energy consumption based on the normalized value. Starting with C and Rust, it's imperceivable. Basically, they're right side by side. C++ is a little bit, then Java, Go, JavaScript, PHP, Ruby, and Python. It kind of seems like we should use Rust for everything, right? If it provides this much improvement on energy consumption, and it also significantly reduces a lot of the challenges that we face in production, Rust should be the universal language for everything. I think that we should use Rust for everything. Of course, right now, from a business perspective, if you're adopting Rust early on, you're going to have this early adopter advantage. Using this technology, you'll have improved margins, better performance, and your product is going to be more stable. From a business perspective, it makes every sense to invest as much as you can in Rust. Rust in production is amazing. We should absolutely use it for as much as we possibly can, every possible application. Building our products in Rust is going to give us a a major advantage in the industry. It's not for free though, because there are several roadblocks and learning curves down the road. Rust does have, and from my firsthand experience, a famously steep learning curve. It brings with it a lot of complexity baked into the language. There's a lot of generics and traits and ways to interact in the stabilized framework for its concurrency. Kind of take a step back and towards one of the common standards of the industry when we're building applications that leverage multiple CPUs. This is of course where the power of Rust comes in, as a lot of those kinds of applications are where we run into memory safety issues. Rust takes care of all of that for us. However, it does require you to sort of relearn how to build and develop code. Because Rust is still an up-and-coming language, we see that often many developers have still yet to take advantage of the technology, and so they will be running into this learning curve. At PubNub, one of the things I like to encourage is to say, hey, you don't need to know Rust. If you do want to write Rust code at PubNub, you can learn it on the job. And really, that's kind of like the best way to learn a language anyway, when you have an identified need and a deliverable. If you're able to find a position that offers this learning opportunity, the great news is you'll run into all the frustration at the beginning here. And we can see here that the most common reason why the Rust isn't used is because it is difficult to learn. And so if you're just trying to do this as like a side project, a hobby, or just extending education, you're gonna run into a lot of challenges. The compiler is ruthless. And we can see here that a lot of these other factors are basically small barriers to entry, saying, hey, I want to use Rust, but I can't because my current product is written in Go or Java or another language. Or it might not be as easy to sort of import and adopt into the organization based on the tooling. So there's extra lift that you need in order to get Rust into your organization and to be able to develop it with it on a day-to-day basis. There are hard challenges adopting Rust and taking a deep dive into learning the language. Rust has a barrier to entry because there's a lot of new sort of ideas and abstractions that you need to learn in order to use the language. So we can see here that there are various activities and ideas about the difficulty for different Rust concepts. And here's the results. Let's check it out. Lifetimes and ownership. Okay, so this is the memory safety mechanics of Rust itself. These are the most critical aspects of the Rust language. Typically, when it comes to lifetimes, my personal philosophy is just let the compiler deal with it. And if there's ever a scenario where I might need to modify or include a lifetime annotation on a variable, I will redo the code. I think that's just better overall to take that approach rather than having to add that level of complexity into the application as you build it. Ownership is in the concept of borrowing and where current variables are within scope. And as you pass a variable into a function and make a call to execute some code, that variable may need to be borrowed or copied. If for whatever reason a variable is not borrowable, you will need to make a copy of it. And that usually happens on the stack. Stack memory is going to be faster in this case. And guess what? The overall performance hit is pretty low. If you're able to avoid memory copies, that's even better. Though don't worry about it if that's something that you have to do. Wait, I'm sorry, I just noticed there's an unsafe on here is sort of marked as a topic that's tricky or very difficult. I mean, yeah, just don't worry about that one. Just ignore it. That's something that is inherent in the word. If you can say unsafe, basically says, compiler, ignore what's happening over here. I'm going to be writing code that is going to be dangerous. And that goes against the principles of Rust in general. So it's better just not to use that one at all. So you don't even need to say that's a tricky concept. Just avoid it. Then I also see here something like FFI. You usually won't have to deal with that if you're just exclusively inside of Rust. You don't need to extend the Rust functionality out into another language, like Python, for example. So that's something that you can also avoid. You know, as long as you keep things simple overall and just leverage the baseline of the language and don't extend yourself too far into some of those fancy algorithms and the advanced language primitives, such as here we've got traits, we've also got macros. You'll typically have a really good developer experience overall just by keeping things simple.